Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2185, indicates an issue with the engine coolant temperature ECT Sensor 2 circuit, primarily signifying a high voltage reading on this circuit. The ECT sensors are responsible for providing critical data regarding the coolant temperature, which is essential for optimal engine performance and efficiency. Misreading this parameter could lead to improper fuel calculations, causing engine operational issues. The ECT Sensor 2 is typically located near the engine block, and if it fails or detects high voltage, the Engine Control Module, PCM, may receive incorrect temperature data. The threshold established for normal operation is less than or equal to 4.92 volts. If voltage readings exceed this threshold, it may indicate a fault within the sensor or its wiring. In troubleshooting, it's crucial to verify the problem before proceeding with repairs, as intermittent faults can complicate diagnostics. The DTC P2185 specifically relates to the ECT Sensor 2 circuit exhibiting high voltage readings, which signifies that the signal being sent to the vehicle's PCM is consistently above the operational threshold of 4.92 volts. This excess voltage can lead to inaccurate engine coolant temperature readings, which compromises the vehicle's performance. Unless properly addressed, this issue can lead to an array of performance concerns, including poor fuel economy and increased emissions. The ECT Sensor 2 is typically located in proximity to the engine block, making it susceptible to engine heat and vibrations that could damage the component or its wiring. The true nature of high voltage in this circuit must be confirmed through diagnostics, as it can either implicate the sensor itself or be the result of an electrical fault elsewhere in the system. Proper diagnostics using a Honda Diagnostic System, HDS, is instrumental in tracing this fault. Several potential causes could lead to the triggering of DTC P2185. One primary suspect is a faulty ECT Sensor 2, which may be providing inaccurate voltage readings due to internal failure. Wiring issues are another common culprit. This could be an open or short circuit affecting the signal sent to the PCM. It's crucial to evaluate the integrity of the wiring loom connecting the ECT sensor to the PCM to rule out any potential disconnections or damage. Additionally, a malfunctioning PCM itself, though less common, could also misinterpret the data received from the ECT Sensor 2, resulting in elevated voltage readings. Comprehensive diagnostics range from simple continuity tests to swapping in a known good component to verify functioning. Understanding these potential causes is essential for effective troubleshooting. Symptoms of a high voltage condition in the ECT Sensor 2 circuit can manifest in several ways. One of the most prominent symptoms is poor fuel efficiency, as the engine may incorrectly adjust its fuel mixture due to erroneous temperature readings. Additionally, an elevated coolant temperature reading can pose a risk of engine overheating, which, if not addressed promptly, could lead to severe engine damage. Drivers may also experience incorrect engine performance, characterized by unusual hesitation or stalling, as the PCM struggles to adjust fuel and timing based on inaccurate sensor data. Monitoring the vehicle's warning lights and performance metrics is vital to identify and address the underlying issues before they escalate into more significant problems. The first step in troubleshooting DTC P2185 involves verifying the problem effectively. Begin by turning the vehicle's ignition to the on mode without starting the engine. This action allows the onboard diagnostic system to power up. With the Honda Diagnostic System, HDS, check the current parameter values for the ECT Sensor 2. You will compare the detected voltage to ensure it is above the threshold of 4.92 volts. If the values meet or exceed this threshold, this confirms the presence of the fault. If the readings are consistent with expectations, the problem may be intermittent, indicating that a deeper inspection of electrical connections and wiring may be required. Observing freeze frame data could help replicate the fault under similar conditions. Confirming initial observations is vital for effective diagnostics. In the second troubleshooting step for DTC P2185, with the vehicle turned off, begin by disconnecting the ECT Sensor 2's 2P connector. This action isolates the sensor, allowing for controlled testing without interference from the engine's operational systems. Next, use a jumper wire to connect terminals A and B within the ECT Sensor 2 2P connector. Terminal A is identified as the ECT Sensor 2 connector number 1, while Terminal B is number 2. After making this connection, switch the ignition back to the on mode. Return to your HDS and check the voltage reading on the ECT Sensor 2 circuit again. If the voltage remains above 4.92 volts, you can confirm that the fault likely resides within the sensor itself. If the voltage drops to appropriate levels, you may need to investigate other components, such as the wiring or PCM. For the third step in troubleshooting DTC P2185, start by turning the vehicle's ignition back to the off mode to ensure safety when working on the electrical system. Remove the jumper wire connected to the ECT Sensor 2 2P connector to return the circuit to its standard configuration. With the ignition in the on position, measure the voltage between test points designated for diagnosis. Test point 1 is located at connector number 2 of the ECT Sensor 2P connector, while test point 2 is the body ground. A voltage measurement near 5.0 volts indicates that the circuit is operationally sound. Should the voltage reading diverge from this value, the sensor circuit is likely compromised, and further evaluation of the wiring or connections is warranted to pinpoint the fault within the system. Understanding these test points is crucial in accurately diagnosing the circuit. The fourth step in resolving DTC P2185 focuses on conducting an open wire check for the SG6 SG line. Begin by ensuring the vehicle is in the off mode. Once this is verified, use the HDS to jump the SCS service check signal line and wait for more than 1 minute. This allows the system to reset. After this time, disconnect the PCM, Powertrain Control Module, Connector A, specifically the 51P set of terminals. At this stage, continuity between test points must be determined. Test point 1 relates to the ECT sensor's connector number 1, while test point 2 concerns the PCM connector A's number 20 terminal. A continuity check will confirm whether the SG6 SG wire is intact. If continuity exists, the wire is functioning correctly, and the next step involves looking at any related authorized service information for guidance. If continuity does not exist, this indicates an open circuit, necessitating repairs in the wiring to restore proper function. The fifth troubleshooting step targets the continuity check for the TW2 SNSR, temperature water 2 sensor line. As with previous steps, ensure the vehicle is turned to the off mode before beginning. Use the HDS again to jump the SCS line, allowing for a proper reset period of 1 minute. Disconnect the PCM connector A, 51P once again to proceed with ensuring continuity. This time, the tests will involve checking between test point 1, associated with the ECT sensor's connector number 2, and test point 2, indicating the type A31 terminal in the PCM connector. A successful continuity reading would confirm the integrity of the TW2 SNSR line, suggesting that no faults lie within the wiring. If continuity fails, it will necessitate repairs to rectify any open circuits affecting the connection between these 2 points. This step is critical in verifying the operational status of the wiring responsible for sensor communication. After completing all necessary repairs for DTC P2185, it is essential to conduct a final verification to confirm the integrity and functionality of the repairs performed. Start by performing a thorough diagnostic run to check for any residual DTCs, notably if the P2185 code reappears. If the DTC has been successfully cleared, be sure to operate the vehicle under various conditions to ensure that the issue does not resurface. It's crucial to monitor the ECT values during diagnostic tests to validate that they remain consistent within the acceptable range, indicating that sensor functionality is restored. Furthermore, visually inspect the physical components to ascertain that all connections are secure and no new wiring issues have arisen since repairs were made. This stage ensures that the vehicle operates smoothly without the challenges that previously marred engine performance. To prevent the recurrence of DTC P2185 and ensure overall vehicle reliability, regularly scheduled maintenance is crucial. One of the primary components to check should be the ECT sensors themselves. Regular inspections can identify wear or damage before they lead to failure. Pay close attention to the wiring harnesses connected to the ECT sensors. Ensure that they are free of corrosion and securely connected to avoid intermittent faults. Additionally, performing routine system diagnostics can catch any emerging issues early in their development. It is recommended to consult the Honda service manual for guidelines on specific intervals for these inspections, as this will depend on usage patterns, driving conditions, and overall vehicle age. Establishing a habit of these practices aids in extending the life of critical engine components. In summary, DTC P2185 reflects a critical issue with the ECT Sensor 2 circuit, indicating high voltage readings that can adversely affect engine performance. Careful troubleshooting steps, starting from voltage verification to continuity checks on wiring, are vital in isolating and identifying the root cause of the error. High voltage conditions, whether stemming from sensor failure or wiring issues, require methodical diagnostics using specialized tools like the HDS. Regular preventive maintenance, focusing on sensor condition and wiring integrity, can mitigate the risk of encountering such DTCs in the future. By adopting these practices, vehicle owners ensure that their Honda Pilot operates efficiently and effectively, maximizing both performance and longevity. Please like and subscribe to the channel. See you next time.